everyone, and welcome back to Global Education Zone. And in this video today, I'll be talking about computers and the digitization. So this will be just like an overview on computers and also digitization. So then in this overview, we'll also talk about the history of computers, and then we'll talk about the classifications of computers and so on and so forth. So stay tuned and listen. Now, computers, they've been around for over a century or so now, or more than a century. And those computers I'm talking about, they are modern computers. But computers themselves, those computers, those devices that help us to that make things easier for us, that make life easier for us, they've been around since as long as we can remember. One of the earliest computers was the Abacus, and the Abacus is basically when you have a frame, then in that frame, when you have some rods, then in those rods, then you have some beads. So, and then this was used by early Egyptians in the 10th century BC, and those early Egyptians, they used it to perform simple calculations. Then this abacus, it was taken over and innovated upon by the Chinese educationists in the 12th century Anno Domini. So that's 12th century AD. So then that was, by the way, that is abacus. We'll come to the classification of computers where we'll also talk about abacus. So then computers, basically, they are basically any device that helps you makes life easier for us and helps us do different things. So now, after these computers, we have what's known as computing. And what's computing? Computing is basically the use of computers, the study of computers to understand how they are made, how they work, and how to use them. So, and it's also known as the use of computers. So when you study the use of computers, how to make them and how to how they work, that is called computing in simple terms. So when we are also performing what is known as computing, because as I speak to this I have my cell phone in front of me, and then I'm making a video, and then as this video is being made, this phone is collecting data from the environment through its camera and then the microphone, and then those data is entering the phone in digital units, and those digital units, we'll talk about it, and then those digital units, they are going into the IC, or the integrated circuit, and then that integrated circuit, that brain of the computer is also processing it and forming it into a video. And this is just a simplified process of how it all works, though it is definitely going to work much more complex than what I've explained, but that is just a simplified way of how computers work, just in case you are still trying to understand the basics. So, and then these computers, they have different types. So, and then that's why I'm talking about the history of computers. So in the history of computers, we have to talk about the early computers, and one of the earliest computers, as I mentioned earlier, is the abacus. And then this abacus, basically, you have a frame, then you have your rods, and then in those rods we have beads or circular objects. Those are the objects that have like discs, so they have holes within them, so they fit into those rods, and then they slide up and down. They are used for calculations. That's an abacus. So, and then we also have, after abacus, we have the Napier's bone, which was invented in 1617 by John Napier, who was a quite eccentric scientist, by the way. So then we also have your slide rule, and the slide rule is a quite recent development. It was invented in 1632, and the slide rule is still used today by many scientific and astronautic bodies, just like the NASA. So the slide rule was used by the Mercury, Gemini, and Apollo missions. So I was just saying, so I know that even these early computers are still used today. Slide rule. And then we also have the Shikard's calculator, which was invented by William Shikard in 1623. We also have the Pascal's calculator. Pascal's calculator was invented by Blaise Pascal in the year 1642, and it was basically a device that could be able to perform addition and subtraction by the means of gears. So, and it's basically a mechanical device. Then this mechanical device that was invented by Pascal was also innovated, and it was renovated and changed into the Leibniz calculator in 1671 by another smart mathematician, a German, who is known as Gottfried Leibniz. Then apart from that, we also have the Analytic Engine, invented by the father of computers, which is Charles Babbage, in 1833. And this Analytic Engine was one of his earliest inventions, and he made use of a technological or computing technique known as punch card, which was Jacquard's looms, and punch card techniques. So he used that in his analytic engine. Then we also have John von Neumann machine. We also have Hermann Holler's calculator, and so on and so forth. So these are just a few of the different mathematicians, scientists, and engineers who worked to make these devices to make life easier for us. So and then these computers today that we have, they are modern computers which are evolved after a series of innovative and renovative and creative actions of different people all over the world. That's why today we have microprocessors, and that is why today we are developing artificial intelligence. So, and that's by the way, and just by the way, computers work solely by binary processes. So they make use of binary number system, which is zeros and one, because the reason for that is that a computer works basically on what is known as on the principle of electronics, and those electronics, they have these components and chips and semiconductors, and then basically and then dive a little bit into electronics, and then we'll talk about the currents. Those currents, they move into the conductors, they move along the conductors, and they move into these devices such as resistors, capacitors, and so on and so forth. And these devices, they can either receive current or not, and when they receive current, they are on. When they do not receive current, they are off. Or rather, when current pass through them, is on. When current does not pass through, it's off. So and then these two states of on and off, they characterize the zeros and one of computers. So every single process that your computer is carrying out today, it is characterized, it is carried out by simple binary number system. So and that by that we have the four main binary systems that are used in computers, which is computing, which is binary, the major. Then but we also have decimal system, hexadecimal system, and octal system. But note that the only system that is understood by the computers is zeros and one, also known as binary. But when computers wants to transfer the or output your information to that you see on your screen, that you see in your user interface, so they make use of your compilers and so on and so forth, and interpreters to change the structure from machine language to high level language. So that is just by the way. Then we also have what is known as digitization of data. And after we talk about the history of computers and so on and so forth, we also have to talk about the fact that these computers, they've moved from analog to digital. So these analog computers like Abacus, like your Pascal's calculator, and your punch card, your looms, and so on and so forth, they were basically made on mechanical and simple electromechanical techniques. But then these are digital computers. They are purely electronic devices that work on binary system of numbers. So and then this digitization we're talking about is a modern concept which involves the fact that our computers are moving from mechanical and electromechanical into digital. They are moving to electronics. They are making use of all these screen. They are making use of all these ones and zeros and numbers instead of counters and pointers and all the rest. So and then examples of analog devices, just by the way, it is your speedometer. All those devices that make use of continuous they measure continuous data, and then your digital devices measure your discrete data, but analog devices measure continuous data. So this digitization we're talking about is basically the process of converting data from analog to digital system. So example, when you talk about your modem, if you've ever seen a modem is a small device that is used to connect your computer to such as your PC, connect your PC to the internet, and that modem you basically put your SIM inside, your system subscriber identity module, that SIM inside, and then that modem basically it receives those analog signal. It receives those signals and then it demodulates them. So that's why we call modulator demodulator. That is your modem. So those demodulations, they are converted. When the pulses are high, they are ones, and when they are low, they are zeros. So ones and zeros. So and then that is converted to your computers, which also demodulates them and interprets them. And then that is called digitization, and that is basically the conversion of information into digital format, which is simply ones and zeros. So no need of bogus grammar. Digitization is basically conversion of data into ones and zeros. So and then we have computers that perform this process. So those are classification of computers. Talk about micro, mini, supercomputers, and mainframe computers. So if you want more information on those classification of computers, I have a separate video on that. But today, this is as far as I can go on computers. And I must say that computing is a very interesting topic if you are willing to delve into it. Then in summary, we've talked about the computers, the history of computers, Pascal's calculator, Goldfried calculator, and so on and so forth. And then we've talked about the digitization of